Today we will discuss about different types of NLP tasks. The first one, which is a classic task, is text classification. On real life use cases would be in the Camtasia software, which is used for video creation and editing. So for Camtasia they need to prioritize complaints which they receive into severity cases. The way you can do that is by looking at the text. For example, Camtasia 10 won't import MP4 file through import media section is a very bad complaint, so it is high severity, and so you could hire a human to rate the severity for the complaints. But if there are too many complaints, then you would need to hire more humans, which would be very costly. So instead you train an NLP model to transform this text into some kind of vector, and then you can use a method such as td_idf, which is some method of converting text into a vector or a set of numbers. Once you have these number representations, this text you can then use a classifier like naive Bayes to classify the complaints as high, medium or low severity. So in this particular case, which is a high severity complaint, you can have a low severity complaint as well, in which case your workflow will be to create a low priority ticket which someone will look into after 1 week or so. So just to summarize, you have an incoming complaint, you can use some form of vectorizer to convert it into a set of numbers, then you can use classifier. After this you will train the machine learning model on the older data of the previous complaints which are already labeled in severity ratings. Another use case is in the healthcare sector, which you have a lot of healthcare related documents. So for example, you have a prescription, which is a medicine prescribed to you, and you also have a patient record. Now these are scanned documents which are uploaded to the cloud. And now one of the use cases in healthcare industry is to classify these documents as to whether they are prescription or patient medical record. The staff will have hundreds of such papers, and they will just scan it and put it on the drive, so they will not have the time to classify these documents. So the first step you will do is you will use Google Tesseract to convert image data into text data, and then you can use an approach like talk to text, which can be used to convert text to vector, and then we can use logistic regression classifier, which can tell you if you have a prescription or a patient medical record. The third use case of text classification is hate speech detection by Facebook. We all know that Facebook has many racist groups or other social extremist groups where there are many hate speeches going around, and Facebook has built this classification algorithm where the algorithm can read the text and tell if it is a hate speech or not. In 2021 they reported more than 8 million hate speeches, so now they can automatically delete those hate speech posts from Facebook. LinkedIn also created a model based on NLP which can classify whether a profile is a real or fake profile, and based on that they can block the account. Another type of NLP task is text similarity, where let's say you have this use case of matching resume with the given job skill. Nowadays for one data scientist role there are 100 applications, so you can use text similarity here to figure out which resume is matching the job position. So using Hugging Face sentence transformer, and you can sort by most likes and get a sentence similarity between any two statements. In the above case there is a source sentence and a sentence is to compare to section. There's also a resume screener which matches the resume with the job description. So you could upload a resume and a job description and get the similarity, using which you can make your hiring process more efficient by letting this filter out 90% of the records and only pass ahead 10% of them. The way this works is you have a job description which is some text, and resume using sentence encoder you convert text into a number. And so far pretty much for any NLP task you convert your text into a series of numbers or vectors. And the way it converts your words into numbers is that if you have similar text, the numbers in the vector will also be similar. Some numbers will be different, but if the text is very similar, the vectors will be similar. And there is something called cosine similarity which can be used for getting the percentage match. The third NLP task is information extraction. In the email, if you have your flight itinerary and Gmail will automatically derive or extract the meaningful information such as passenger name, destination, seat number, etc. And for this it uses information extraction principle, regular expression, etc. If you have read Google News, you will see that all the trending topics are extracted using Google NLP engine. and you can click on one topic and you can read all the news related to this particular topic. So these are all the trending news aligned at one place. The fourth NLP task is information retrieval. It is different from information extraction. The best example for information retrieval is Google search engine. When you search for restaurants near you, it will give you all the restaurants near you by getting your location and will display these results to you. The purpose of information retrieval is to return the relevant information in the sorted order. So the first website should be the most relevant, the second should be less relevant, and so on. The next NLP task is chatbot, which is used in chat services. There are three types of chatbots. FAR chatbot, FAQ chatbot, where you have a fixed number of answers, and whenever you ask a question, it gives you a fixed hard-coded answer. The second is flow-based bot, which remembers the context. So in flow-based bot, there is no connection. In FAQ bot, there is no connection between your first and second question. And the third is open-ended bot, which is a simple general conversation holding bot. Next is machine translation. Google Translate is a good example. This uses encoder-decoder technique of RNN, recurrent neural network, and the net one is language modeling. The standard use case is that Gmail will try to autocomplete. So the sentence autocomplete task is basically language modeling. It tries to predict the probability of the next set of words that comes up when you try to complete a sentence. There are two types of models, statistical and neural. Then there is text summarization, in which you can use NLP text summarization to summarize a whole news article into one statement. You can use topic modeling technique to extract the abstract topics out of a group of documents. And finally, voice assistant is also an NLP task. I don't think I have to say much about voice assistants because it's already well known about.